Alright, so we're up to the sixth integral on Jim Coroneos' list of 100 integrals. And today we've been given the integral, which I've named I. And I is equal to the integral of cosine squared of x on 2. And this is integrated with respect to x. Alright. Now, this is really just a variation on the typical extension 1 mathematics types of integrals. That involve, trigonometric integrals like cosine squared and sine squared, right? But typically in extension 1, you might see integrals like, let me get the black color, things like sine squared x, or, cosine squared theta, or something like that, So we might have integrals like the one we're going to do today, but, whatever's in the trigonometric function is simply just x or theta by itself and not a fraction, right? That's not too much. That's not too big of a deal. We can handle through that, but we just gotta shift our intuition a little bit. Okay, so typically when we have problems like this, just as those we've encountered in extension 1, we look to the double angle formula, right, of cosine 2x, right? And we know, right, from our double angle formulae, that cosine 2x is equal to cosine squared of x minus sine squared of x, right? Okay. Actually, instead of x, I might make it theta. And, yeah, let's do it again. I might make it theta, actually. Alright, so cosine 2 theta equals cosine squared theta minus sine squared theta, right? You can replace theta with anything, but I'm using theta because I want to treat it as if it was a placeholder value, okay? So a value that we can replace with any other pronumeral, right? So you don't get confused with the x that we have in the question. And this is also equivalent to twice of cosine squared theta minus 1. Or alternatively, in terms of sine theta, cosine 2 theta is equal to 1 minus 2 sine squared theta. So these are three equivalent statements that we can utilize when we're dealing with integration problems such as this, right? But the only problem is that typically when we have, say, the integral cosine squared x or cosine squared theta, we can use, say, the second statement here, and we can rearrange for cosine squared theta. However, the problem here is that it's not just theta or x or y or z, it's x on 2. It's half of x, right? And so how do we tackle with that? Well, the way we do that is, remember, we want cosine squared as a subject, and here theta is really the placeholder value in this trigonometric function. So what we do is we're going to let, right, switch back to black, we're going to let theta be x on 2. Right, simple as that. And so that means that we're going to focus on the second statement, right? The second equation. And what happens is that we're going to substitute theta. We're going to substitute x on 2 for theta. So we're going to get cosine. So therefore, cosine 2 times x on 2. Right, is equal to, and we're going to use the second equation, 2 times the cosine squared of x on 2 minus 1, right? 2's cancel out. So what we're left with is cosine of x equals 2 times cosine squared of x on 2 minus 1. And here, right, then it just becomes a simple integration problem now. And, now we can just use, instead of, dealing with cosine squares of just theta or x, now we have x on 2, which is what we really need. And now we can just make cosine squared of x on 2 the subject of the equation. So I'm going to add 1 to both sides to get rid of the negative 1 on the right hand side. And that leaves us with cosine of x plus 1 equals 2 times the cosine squared of x on 2. And to get rid of the coefficient of 2 in front of the right hand side, we're going to divide both sides by 2. And that's going to leave us with half times cosine of x plus 1. And that is equal to cosine squared of x on 2. And this identity we can substitute into the integral problem that we have today. And so we start off with I equals the integral cosine squared x on 2 dx. And we found what cosine squared x on 2 is equal to, and that's going to be half times cosine x plus 1. So let's do it. Let's replace that. So cosine squared x on 2. So that becomes half times cosine of x plus 1. I'm going to integrate that with respect to x, right? Multiply symbol there. And the half is a constant, so we can take that out of the integral, and that becomes half times the integral of cosine of x plus 1. I'm going to integrate that with respect to x, right? And now, I don't think it's really necessary to split the integral. I don't think it's too much of a hassle. So we're just going to integrate all at once. So this will be half times, and we're going to integrate everything in the integrand. So the integral of cosine x will be sine of x. And of course, when we integrate 1, we're just going to get x. So that becomes half times sine of x plus x. I've used the square brackets just to group this up as a quantity, and this quantity is being multiplied by half. And of course, when we finish the integration, the indefinite integration, we're going to have a constant of integration c at the very end. So, I mean, it's not that much of a hard problem. It's just a little small variation on our typical 3-unit extension 1 problem. But yeah, we managed to complete it.